Hi, here is your crash course to Computer Science GCSE OCR exam. So, we're going to start with Unit 1, Lesson 1. And Unit 1 is focused on the architecture of the CPU. So, when we talk about the basic computer model, we're talking about the hardware and software components. Computer systems are all around us, not just the PCs that are in our computer labs. It is basically the smartphones that we use, the embedded system in our house, like our like the washing machines, the TVs, and so forth. It is also the cash machines that we use, the supermarket tills, the engine system in your parents' car, right? So the system contains of input devices, output devices, storage devices, the CPU, which is also called the processor, and also memory, which is the basically the RAM. So when we look at this supermarket till, we can identify some input devices and some output devices. So I'm going to ask you to pause the video for a second, and you're going to go to the comment section and you're going to identify at least 3 input devices that you can see here and 3 output device. When you're back, you will hear the answers. So some of the answers are the barcode reader for the input device, the card reader as an input device, the camera as an input device. Output devices are like the monitor, the printer for the receipt, and the speaker for the sound. Here is another activity. It says, here are some statements about the CPU of a computer system. So you're going to tell me if the answers are true or false. You can pause the video as before, go to the comment section and write your answers, and then you can come back to hear the answers here. So the first statement says CPU stands for Central Processing Unit. So you're going to answer if that is true or false. The CPU fetches and decodes instructions. The speed of the CPU is usually measured in gigahertz. If a CPU has many cores, it slows down a computer. The hard disk drive is a part of the CPU. When you have your answers, then you can come back because I'm going to reveal the answers now. And here are the answers. Now, von Neumann is a mathematician and he's also a scientist. And he decided if computers are these big, massive, powerful things, they should be able to store information and they should also even be able to store programs. So the first computers, it was not possible to store programs and data. And they were generally input by setting switches. So is architecture, which you're going to see coming up, it allows you to store and retrieve this information and these programs. So here we have it, and it consists of the input devices, the storage devices, cache, memory, the CPU, and also output devices. All right. Oh, before we move forward, I want you to pay attention to the arrow, and you can see where the arrows are on this diagram. You can see that the arrows are going back and forth. It means that the programs and data, they're able to flow to and from like the memory and the processor, and also from the storage devices. Okay, so you will see more regarding the CPU, like a diagram breaking down the CPU into different parts and so forth. But I also want you to notice that when it comes on the CPU, it works hand in hand with the cache and also with the RAM. So the cache is a fast memory close to the CPU where is used to store temporary data and instructions that are currently being used. Okay, and also the RAM is considered as the main memory where it stores operating system software, application software, and other information that is generally being processed by the CPU to have fast and direct access when needed to perform tasks. So the CPU performs something very important, a task or a cycle that's called the fetch, decode, execution cycle or execute cycle. So to run the program, the processor needs to first fetch the information, decodes it, and executes it. The processor executes one instruction at a time. This is called the fetch, decode, execution cycle, or execute cycle, or simple the fetch, execute cycle. So at the fetch stage, what happens is that the instruction is retrieved from the RAM or from the memory. Then it brings it back to the CPU. At the decode stage, it actually interprets the information or the instructions. So it inspects the instructions and work out what exactly needs to be done. And then the execute stage, it carries out the instructions. This could go back over many things to see, okay, what needs to be done. If something didn't work as it planned, it goes to find out, okay, what can I do as an alternative, etc. All right, so here's the question. You can pause this and come back to it if you want. Okay. So this is what I was talking about. The processor or the CPU. This is a example or like a diagram that explains the different sections of the CPU. We have the control unit, we have the arithmetic logic unit, and we have registers. At your level, at GCSE level, we only focus on 4 registers. Okay, so we have the PC, the AC, the MAR, and the MDR. So let's talk about the control unit. The control unit is the part of the CPU that gives instructions and tell what needs to be done and controls all the different parts and aspects of the computer system. The arithmetic logic unit section is the part that carries out the mathematical calculations or logical operations. And then the registers. What I want you to do for the registers is to go into the comment section and you're going to tell me what the PC is used for, what the AC is used for, what the MAR is used for, and what the MDR is used for. If you're not so familiar, you can go to Google and you can find the answer in Google and you can put it in the comment section. I will allow that just for this time. And then you can move forward with the video. Here is a simple activity for your exit ticket. You're going to tell me what the control unit is used for, what the cache is used for, what the arithmetic logic unit is used for, and what the registers are used for based on what I just said just now. Okay, so please provide me with your answers in the comment section. If there's anything that I missed in this video regarding unit 1 lesson 1 that you want me to cover, or if you want me to work a past paper question for you, please feel free to reach out to me in the comment section and I will make another video. Thank you so much for listening and I wish you all the best on your exams. Please look out for the second video from unit 1 lesson 2 and I hope you have a great day. Bye.